point is, see, we have to understand where the concept is getting shifted in history. So that is what I am trying to impress upon. Like the concept of whatever we see today, many important parameters, like we understand it in some way, but that understanding came after going through a lot of changes. So first thing is of motion. So for during the old Greek times, even before Greek times, they were thinking it is all divine. But during the Greek times, Aristotelian times and all, they thought like motion is something as a very fixed concept. Like some force, maybe earth or some other force comes, and then because of that, motion is the result of it. Because of that, the motion starts. That is how they were thinking. Like anything, for example, earth is static. They were thinking earth is static because if motion has to happen, somebody has to apply a force on it. So that is where the geocentric universe and everything comes into picture. Or that is what our common sense will tell us. So you are standing like this. If you have to move, somebody has to come and push you. So that is how it will naturally, common sensically, it will look to you. So now during the Galileo and this Newton times is when they got rid of that concept called fixed motion. So that is when this concept of relative motion came, which is like you are in earth, but you are acting as if earth is static. We are behaving in earth as if earth is static. See, for example, if we are having a giant wheel, we won't be doing circus standing in the giant wheel, because you can see that giant wheel moving. So you won't have the guts to stand on the giant wheel and doing a circus to put your leg up or hand up, right? Even a small thing like a cycle, if you are riding, you won't, like if you want to touch or scratch your nose, you'll be very careful. Will you put your hand hold like this and do when you move, because you fear of this balance. But this earth is actually moving at much faster speed, but we don't care. Or you go in a car, you sit inside the car. Inside the car, if the windows are up and all those, inside the car, you sit and talk, kids will play, you will give food to other person, that person will give food to you, you will eat. The person in the driving seat will take the water from back. You act as if like inside the car, it's a very static place. Okay, but then for a person who is outside the car, will feel like you are not static. No, your actions like you are moving. So like for example, you are giving food to in a car, backside the car, two people are sitting, one person gives a biscuit to this person. For a person who is standing outside, the person gives biscuit at this point when car was near the tree, and that biscuit will reach the other person when car is moved 50 meters or 20 meters. So for him, this biscuit is moving like this. Understand? So that Galileo and Newton's theories, that has changed the concept of something called fixed motion. So that they came with this concept called relative motion. They told, okay, fine, you're telling somebody is moving, you tell with respect to what? Okay, or let us tell you tell that, okay, a bus is going at 50 km/h. With respect to what? With respect to earth. 50 km/h with respect to earth. Suppose you are sitting in moon, you can't tell bus is going at 50 km/h. You will tell bus is going at earth speed plus 50 km/h. Suppose you are sitting at another galaxy, then that speed will again change. You get that concept? So that is the concept of relative motion. So these people, what Galileo and Newton and all did is they abandoned the concept called fixed motion. But then what they didn't realize is that they abandoned also the concept of fixed space. Because the moment you tell that motion is not fixed, then you also tell that space is also not fixed. The same example, if we take in a train, if you take a ball and put it and ball comes to you, where that event happened is in two different spaces. For the person in the train and person outside the train, the event happened the same event. Ball went up and came back, but it happened in two different spaces. Inside the train, it happened at same space. But for a person standing outside the train, it happened in a different space. Ball went when train was here, and when train moved, ball reached top. When train moved some more, then the ball came back. So it is happening in different spaces. You understand? So that was a very difficult concept to fathom, to accept, to digest. In fact, Newton and all refused to believe that. See, it is actually the consequence of their own finding. So they found something, but then the consequence of that is pretty huge. You are telling space is not fixed. Space varies for different people depending on where you are. Okay, so that is a very critical change in the understanding. Now what happens is, see, people had measured the speed of light through different means. Different means in the sense, very funny ways. For example, like, Jupiter. So there are moons which rotate the Jupiter. There are moons which rotate Jupiter. So when you look from Earth, you will see that the time when the Jupiter moon, let us assume, is exactly behind Jupiter. The Jupiter's moon is exactly behind the Jupiter, means when we look from here, we can see that moon, like an eclipse it becomes. You understand? I will just try to draw that. See, if we look at this, if you think this is if you think this is Earth, okay, if you think this is Earth, and if you take this as Jupiter, let us assume this is Jupiter. Let's assume this is, oops. Let us assume this is Jupiter. Okay. So if this is Jupiter and if this is Earth, so when you look from Earth, actually you can see Jupiter's moon. Jupiter has many moons rotating it. Jupiter has many moons rotating it. Okay. See, now what happens is, this moons of Jupiter, let us assume there is a small moon, you are observing the position when moon is here, which means it is an eclipse. You can't see this moon. You can't see this moon because of Jupiter when you look from Earth. Now, what happens is, the position, the distance between Earth and Jupiter will change, because Earth is also rotating the sun, Jupiter is also rotating the sun. So distance between these two will change. So at some time when you look at this moon, the distance between Earth and Jupiter is here, and maybe some other time, maybe next year or next year or something, this Earth will be here. So the distance between Earth and Jupiter has increased. So there was a scientist called Romer who had observed that this position, when you see this sort of the moon's position, it changes depending on distance between Earth and Jupiter. Which means if Earth and Jupiter are in this position this year, next year let us assume Earth is moved and Earth is here, which means distances increase, then the position when you see its moon, the time when you see that, it is changing. So that is because he realized that is because light is taking time to reach your eyes. The light from this moon is taking time to reach your eyes because Earth is now gone farther. So it is taking more time for you to realize that. So this kind of observations, people had even calculated the speed of light based on this phenomenon. So they started observing nature and they realized that there is a fixed speed for light. Based on the observing this, they realized that the speed of light is fixed. There is a constant speed, but it is very, very high. Okay, so that time actually there is another branch of science which I'm not touching here because of the complexity and the depth of it. So in between there is a scientist called James Clerk Maxwell. So he developed the concept of magnetism. So he is the person who developed the concept that this magnetism and electricity are the same thing, and both are caused by one specific phenomenon. And he also realized that the light is going like wave. So he's the guy who posted light is going like wave. So before people knew sound goes like waves. See, so there is a critical difference but between sound and light. Because in the case of sound, what happens is if you produce a sound, that sound doesn't reach the other person. Actually, that sound passes that ripple to the atmosphere. That atmosphere it creates the same ripple, and that passes to the next one. So it passes to the next one. So the end person, when they hear this sound, actually we will tell like sound is transmitted through this air medium, but actually speaking, the original one is not what is getting transmitted. There is nothing which goes from your mouth. Otherwise, when you speak, your weight will reduce, your mass will reduce. Because there is no matter which goes from you when a sound travels. So only you are creating a ripple. You're giving a force. When you make a sound, it creates a force. So air moves. And then that one fixes the next air moves. It is like you can relate it with, let us assume you are cooking. So when you're cooking, let us assume you are using a stick to say fry something. After some point in your hand, you will feel the heat. So the heat is coming from the pot, but the heat is not traveling directly. It will first heat the tip of your whatever you are stirring it with, and it will heat the next element. It will heat the next matter. It will heat the next matter, and slowly that heat will reach your hand. So the message reaches you. It is like a message coming to you. The message reaches you, but the phenomenon also reaches you. You think about it. Like the message reaches you that it has become hot, but it is not just the message. The feeling also reaches you. The parameter, the phenomenon called heat also reaches you. Okay, sound is like that. The sound, the parameter, the phenomenon reaches you, but the source particle does not come to you. So when we say that this is the speed of sound, we are telling that is the speed compared to air. In air, this is the speed. That is what we mean. So when we tell this is the speed of sound, we tell in air medium, this is its speed. In another medium, that will change. You understand? So when they thought there is a fixed speed for light, now you have to tell fixed compared to what? Now only you told in a train, if you're going like this in a train and a car is coming in the same direction, both of you are going at same speed, from the car you can play ball with the train because you are going at same speed. If the car is coming at a lesser speed, then the speed difference is different. And if car is coming opposite, then the speed is different, which means if you are moving, if objects are moving, then the measured speed of the other object will change. So the speed is depending on where you are standing. So all the speed we normally tell based on Earth. So when we tell this vehicle is going and so speed, we are telling based on Earth. But if you are standing inside a train and if you are moving in a train, inside the train, if a kid is playing with a toy car, and if the kid is telling this toy car is going at 10 meters per second, then that you are telling with respect to train speed. You know, so that is what we call as relative speed. So now when it came to light, this question came by telling, when you tell there is a finite speed for light, with respect to what? With respect to what you are talking about? So then that is where people told, well, there is no air near sun and the planets and all those things, but there is something called ether. So this ether business was even put in much before by Aristotle, that there is ether outside the earth atmosphere, it's full ether. So then they postulated, everybody postulated by telling that it is ether is the medium. So when we are telling light is traveling at a fixed speed, it is with respect to ether. There is a fixed finite speed of light with respect to ether. So now, then if you start moving, let us assume light is coming from sun. Okay, if you are going in a direction against the sun, it is coming from sun, you are going against the sun. It is like a train is coming, you are going against, then the speed of light measured will be more. Let us assume you are coming from sun to earth in the same direction as light, then the speed of light measured should be lesser. It is just like train going and another train going parallel. So if you are going in same direction, you will feel the speed is lesser. But if you're coming in opposite direction, the speed measured will be more. So that is the phenomenon these two gentlemen were trying to measure. That what would be the difference in speed of light when you travel along the direction of light and opposite. In this case, they didn't try opposite, they tried perpendicular. That is for an experimental complexity. Okay, so these two gentlemen, the Michelson actually is the first American Nobel Prize winner for experimental scientist, and Morley. So they are like very reputed for conducting complex experiments. So they conducted this experiment actually to identify how much is the speed difference. How much is the speed difference of light? So they can, so that you can accurately get the speed of light. That was their intent. So when they measured this, to their surprise, they got by telling speed of light when you travel along the light or opposite to the light are same. So that is means that the experiment was in such a way that they measured the speed of light along with the light and then measured in a different direction, and then they reduced these two to get what is the difference. So there should be some difference, because along with that and opposite or perpendicular, there should be difference, and the difference they got it as 0. See, when you get a result of an experiment as 0, there can be two things. See, there can be two things. See, that is why you tell that, okay, you are going to that place from your house, you are going to church gate. Okay, church gate mein jaake ek phone kar dena. You tell that, right? You don't normally tell, okay, church gate mein pahunch gaya to don't call me. If you don't reach church gate, call me. You don't tell like that. So you normally give a signal that if you reach, you have to give a signal. See, otherwise, you don't know if the person is not calling, it is a signal of he has reached church gate or something happened to him so that he is not able to call himself. So this experiment was such an experiment. So they got a 0 as a result. So they were not even thinking that the result could be 0. So they thought their experiment is wrong. There's some goof up they have done. Because there has to be a difference in speed of light. If you measure it along the speed of light, it is just like you go in a train along with the train and opposite the train. If you measure, there should be a speed difference. That is as simple as that. Or even an escalator. If an escalator is going in a mall, so if you get into an escalator, if you start running along the direction of escalator, and if you start running opposite direction of escalator, then the speed will be has to be different. Because the distance of escalator is same, but the time taken would be different. So the speed will be different. But here, it is not happening. So then people had trouble. So how do we explain this? They repeated the experiment. They were not knowing how do we explain this. And then that is what I was mentioning. There was another gentleman called Lawrence. He started putting some seeds to it. So he's a guy who started doubting this. See, what does it mean? After some point, they realize that there is no difference in speed of light whether you measure in line with it or opposite to it. What does that mean? That means there can be only two things. Speed is distance by time. If speed is not changing, then that means either distance is changing or time is changing. You know, which is not something which people were thinking of till then. Like if you tell the distance from your house to that house is 1 kilometer, then it is 1 kilometer, you think how can it change? Or time, you tell that we have this Zoom call, you measure in your watch, it is 15 minutes, I measure 15 minutes. If there's a difference, what will we tell? We tell that your clock might need some adjustment. But we won't tell that, yeah, my time is 15 minutes and for you it was 30 minutes. We don't tell that. Right? Because we feel we take time as fixed. So this experiment, if you were to explain, if that experiment is true, you will have to break one of it. The concept of fixed distance or fixed time. Okay. So then that is the time Einstein came into picture. He was a very young guy at that time. He was not a very known guy. So this was the photo explanation of the what I was telling. Like in the case of light, the result of that experiment says that normally in a case like this, if you are in a train, if you're shooting through two revolvers, so if this speed of this bullet is 100 miles per hour, so this guy A is also in the train, this robber is also on the train. So for this robber, he will feel this bullet is coming at 100 miles per hour. Because both are standing in a train and you can play football. Both are static and train is going at 50 miles per hour. But for this B is standing in a tower outside the track. Is idle. So in his bullet speed 100 miles per hour, it will feel like 100 minus 50 miles per hour for this guy. For that matter, if his revolver he hits with a bullet at 40 miles per hour, it won't reach this guy. Because the train itself is going at 50 miles per hour. So if this tower guy, if he hits a bullet, if that speed is 40 miles per hour or 49 miles per hour, it won't hit this guy. Because this bullet has to first overcome the train speed. You understand? Is it not? Right? If you assume you are sitting here, assume a person standing here is throwing a stone at you, that person, that stone, if it is to reach you, the speed of that stone has to be more than the speed of the train. Then only it will reach you. Understand? So 50 miles per hour of this speed will go to overcome train. Rest 50 only will be felt for this guy. But then, if it is light, not a bullet, if the light speed, if you take it as c, then for this guy, irrespective of it is coming from B or A, both will be coming at same speed. That is the ramification of this theory or this experiment's result. So that means light is defying the rule, whatever we have built in science till now. Understand? So how do you explain this? Is the question. It's a complex problem. It's a complex problem. Okay. So now that is where Einstein came and told that, well, can explain this, but you do two things. One, who told you that there is ether? Have you seen it? It is your hypothesis. There is no ether. Okay, well, so then the question comes, then when you tell the light is having a fixed speed, it is with respect to what? He tells with respect to everything. Light is having same speed with respect to everything. You don't need ether to explain it. So that means what? If the speed of light is constant, then what happens to distance and time? Einstein tells both are not constants. Time could change and distance could change. Which means if you are seeing one event, for example, the Zoom call, If end of the Zoom call, let us assume Imarthi sir was traveling in a flight, he's attending the Zoom call, he may come and tell that Zoom call was 50 minutes for me, and we may tell no, it was 1 hour. And it's not because his clock and our clock is wrong, that is because depending on your speed and your motion, time could change. It's a very difficult concept to swallow. It's a very difficult concept to swallow because that means if you are traveling at higher speeds, the time could shrink. Your time could be less. So what does that mean? Can somebody enter your past? That is the ramification. So when you are telling I am 40-year-old and I have lived 40 years, if somebody else was traveling at a lower speed than you, that means will that person be at 35? Okay. So that is where this whole era of time machines and science fictions and all those things came. You know, possibilities are there. There are possibilities of such kind of thoughts, kind of stuff. But these all things actually work at very high speeds. At normal speeds and all, this doesn't have a big impact. Okay. And then that is the time the next concept he brought it up. Yeah.
Satish, but then speed of light, it must be dependent on medium, na? As such, matlab air mein se pass ho raha hai, water mein.
Yeah. It is depending on medium. Yes, it is depending on medium for sure. If depending on the medium, the speed of light will change. But for different people, it need not be the same even in the same medium. For different people, it is not the case with sound. It is not the case with sound. Actually, if you are going towards the direction of sound, which I will explain you after some time, if you go towards the direction of sound, you will hear more sound. Actually, if an ambulance is coming with siren, if you are traveling towards it, and if somebody is going against it, if both of you are at same point, but the one who is going towards it will hear more sound. That is a theory for it. I'll explain you after some point. It's also a critical important theory. But it is not the case with light. The same medium, of course, different mediums, light is having different speed because the medium will offer some resistance, its speed will change. That is an entirely different physics of it. Because that medium will offer some resistance, so it will change, and in some mediums, light won't travel at all. In some medium, light won't travel at all. But this concept is even in the same medium, if you are traveling at different speeds, your light is this thing is different. See, the point is when you tell light, it means that is how you record the events. When you tell that I saw something, you tell that when I was coming from office, I saw a person walking. That means in physics, light from that person came to your eyes. That's what it means. Understand? So your sight and vision is actually a function of light. So when you tell that two different people traveling at two different speeds will have a different light speed, means you may see two different things. You understand? It is, see, you can easily visualize it. If you look at, let us assume from moon, it takes, let us assume from moon, it takes, say, 1 second or 2 seconds for the sunlight to reach us, the reflected. Let us take sun itself. Let us assume from sun, it takes 8 seconds for sunlight to reach us. So if something is happening in sun now, you won't see it for 8 seconds. Or in other means, if you are seeing something in sun, that is actually a sight of 8 seconds before. So if a drama is going on in sun, you are seeing it actually 8 seconds before. It is like this cricket telecast you have seen. Sometimes the some channels will get the authority power to telecast cricket, and some other channels may not get, so they can actually telecast it 15 minutes delayed. Now sometimes it happens, so they can telecast 15 minutes delayed. So when you go and see it, it is like a normal game, but what you are seeing is something which 15 minutes happened 15 minutes pehle. You are seeing the entire game. Ganguly hits a sixer, but the other guy has seen Ganguly hitting sixer 10 minutes before, and another person has seen it 15 minutes before, depending on which channel they are viewing it. But here, depending on what is the distance for you from the event and what speed you are going. So distance, if it is more from the event, you can easily visualize. Which means if something is happening in a very far away galaxy, you may be seeing it after 500 years, which you are okay, which you can visualize. Because that distance, the things in distance you will see a bit later, it's a bit more easy to comprehend for you. But the motion, when you travel fast, this will happen, is very difficult for you to comprehend, right? So when we tell that there is a time, there is this time, it took so much of time, or this is the time, that means that is actually, it is linked to the movement of light. It is a light signal which is coming. So which also means that this Einstein's this theorem, he also told, like last time me and Darun Dev was mentioning that. So Einstein came up with another very important concept, that we know we have learned energy, we have learned mass. So he broke this thing by telling time is not fixed. As you think, time can change, even distance can change. And then he came also told mass can also change. So till then the concept was that you have a fixed mass. Then he came with this theory by telling that we have learned before energy and work. Using energy, we will do work. Whatever work we do will become energy. That we had learned before. That is energy work equivalence. He brought a similar equivalence between energy and mass. He told energy can become mass and mass can become energy. Okay, so what does that mean? If something is moving, and as its speed increases, its energy will increase, right? Like if a very fast moving train comes and hits you, it creates a severe accident because its energy is more. If train is coming at a slower speed, its energy is less. So that is what we call as kinetic energy. So this energy, which is because of this kinetic motion, so that energy will increase when you travel at faster speed, and that energy, as per Einstein's relativity theory, it converts into mass. So your mass will increase, not the physical mass. The physical mass won't increase, but the theoretical mass will increase as your speed of motion increases. So as your speed further increases, your energy further increases, and the mass further increases. And it doesn't increase linear fashion. It increases exponentially. So after you reach speeds very close to light, the theoretical mass of this body will become very high. And when mass of the body becomes high, you need to apply more force to move it. When the mass of anything is more, you need to apply more force to move it. So when it reaches the speed of light, as per Einstein's calculation, the mass becomes infinite, ananta, so that you need infinite force to move it, which means it is impossible. So Einstein postulated that no object with any mass can travel faster than light because of this. No object with any mass can travel faster than light. But the light is coming because of a particle. So that is what we call as photon, and that is a major difference between light and sound. So when we tell that light is coming, so actually a matter is coming. So from sun, when we tell light is coming, sun is sacrificing and it is burning and its weight is reducing. But when we tell we are talking, our weight is not reducing. Otherwise, though bug karne wala ka weight would have reduced, and we would have got rid of it. But it doesn't happen in the case of sound. When you talk, nothing happens. Your weight doesn't reduce. But when you emit light, actually you are giving matter. photon is coming out. Okay, so that light, when that light comes, that you are emitting something is going. So when sun is emitting sunlight, some mass of sun is reducing, something is coming, things are coming. That's why when you burn something, the mass will reduce, right? Because it is emitting things, it is going off. Okay, so when light, whenever we tell light is coming, that means a photon is coming, and it doesn't have mass, so it is able to travel at that speed. So that was Einstein's theory of how he explained this conundrum of why light is traveling at fixed speed. It is a very complicated concept of science. So that is what we call as relativity. Now the ramification of that is bit more. First, I will come to this space-time here. So this is what they told us, the twin paradox. Twin paradox, which means, let us assume there are two identical twins of same age, and one is getting into space travel, and the spaceship travels at very high speeds close to light, and the guy here staying in the earth, and that person becomes pretty old. And when the spaceship come back, his Judua brother, when he comes bit aged, but this guy becomes a Buddha, and this guy is maybe slightly more age than before, but much younger. Well, it is bit more oversimplification of this thing, but then a much needed oversimplification to convey a very complex concept. That's called the famous twin paradox. So do you get that concept?
Yeah, got the concept, but वो थोड़ा फिल्मी इसमें लग रहा है, मतलब उसका actual reason नहीं पता है.
Yeah, so that is a good point. So the actual reason is how light behaves. All these are happening from one point on what is light and how light behaves, and why light is having a same speed. That is further complicated, further complicated stuff. So I don't want to get into the material, this thing, science, and this thing of it, but you understand the crux of it is that light is a different animal, and he has a huge role in this universe. And whatever we tell as magnetism, electricity, everything is the same guy, photon, same matter, same stuff. Okay, so that is it is. So the concept of light and light itself is actually having a huge impact on how things happen in Earth, right? In terms of the energy, what we get, it provides the entire energy. See, when we tell that the entire energy sun provides, actually it is coming through the light photons. So the solar system, that entire energy, when you tell, he is shedding mass, sun is shedding mass. Okay, and in that there are some reaction happening in sun. Hydrogen atoms are colliding and becoming another atom called helium. So in that process, two hydrogen atom, when we collide, and when helium, it becomes helium, the total mass of hydrogen, and what is the resultant helium, there is small loss of mass, and that small of loss of mass is becoming the energy. That is the energy in which we are living. So we are living with that energy, and there is no other energy for us. So all other energy is because of that, or otherwise some other comet or something should come from some other galaxy and come and hit us. So when we tell that the sun is the powerhouse and all those things, when we tell this is the energy source, and using that light energy source is through photosynthesis, plants make food, and that food is what we eat, and we run and do all those things. Or that photosynthesis, whatever it produces, it becomes fossil fuel, and that is what we use in car, bus, and other vehicles. You get it? So that root is same. Or you need to get energy, means you have to get maybe some other planet from some other galaxy or some other places or some other star should come and give you energy. Otherwise, you don't have a source of energy. Get that? Okay. So, shall I move on? Okay. So, I will move on, and I will I will make an attempt to explain one more concept which is arriving from this. Normally I don't explain to like very younger students, but I thought probably it might look interesting to you because you are artists. It is having a visual parameter also into it. Okay. So if you don't understand, leave it. Yeah.
Yeah, नहीं वही मतलब even this twin paradox, like we can, I think I can visualize it and I can see it, but I can't understand it as such.
Yeah. So the bottom line in this is time changes with respect to motion. If you are traveling fast, the time changes. Why it is? So why it is? Because let us assume you are in Earth. Let us assume a spaceship starts from Earth. Okay? If the spaceship starts from Earth, let us assume it is traveling at some speed. So after it is taking off, let us assume an event is happening on Earth. When the event is happening, the spaceship is not there. Spaceship is not there. It has moved. But then, when will the people in the spaceship know about the event? They will know about that event when, let us assume they are able to see from there. Let us assume they are able to look from there. They will see that when the light from here reaches them.
Yeah.
Right? So they see that at a time which is after this event, which is equal to the time light takes to reach the current position of the spaceship, right? So they will see that event at a time equal to the time the light takes to reach from this place where the event happened to that spaceship. You get that, right? So let us assume there is another spaceship which has gone before them. They will also looking and seeing another site, but they are seeing it much delayed than these people. So you normally tell your sense of time is like this. You tell that, अच्छा उधर मैं जब खड़ा था ऐसा एक आदमी ने मार आके दूसरे को चाकू मारा आपने देखा you'll tell us मैंने देखा आप भी देखा so your sense of time is linked to that event, right? What if somebody tells that I didn't see it? What will you assume? You assume that that person was not there. You immediately associate that with space. But then in here, we are telling those people in this spaceship are seeing it, but they are seeing a different site than you. Their earth is a different earth than you because they are in a different space. You understand? So which means their time is different than you. So this first spaceship and second spaceship, they are following two different times. So when you tell time, there is nothing called absolute time. So when I'm telling I am doing something, Prajakta is dancing here. So the first spaceship is seeing your dance maybe after 10 minutes. Maybe the first spaceship is seeing after 20 minutes. But they are also living. They are also having a continuous life. They are seeing things like you are seeing, but their time is different from your time because they are in a different space. You get are able to catch it? So that is what we tell the concept of space time. So that is why we tell time in absolute sense has no meaning. Why? Let us assume the spaceship is traveling at a speed equal to light. They will never see projector dancing. You started dancing after the spaceship taking off. You dance, dance, dance. Those people in your spaceship, if they are traveling at faster than light, they will not see you. Do you get that? So what does that mean? That means your time is a function of space. Where you are in space. Now the next thing we are telling, let us assume a spaceship is coming towards Earth at a very high speed. Then they will see your dance like we are fast forwarding a video. So you will be playing Bharatanatyam. For them, it will be like rock and roll. Your hand will be moving faster because they are coming to you like this. Are you able to visualize it? So the speed of motion and the space where you are is what will decide your sight. And your sight is actually your concept of time. When you tell time, actually what you mean is your sight. Okay? But thoda, these are like bit tough things to get grasp of it, but you go and think about it. Go and think about it. Took me also a long time to get a grip of it. No? Just go and think about it. Okay? Martha sir, want to ask something? You are unmuted. All right. Okay. So now I will tell one more concept. So this is the idea called space-time. So what he this general theory of sorry, this is called special theory of relativity. What the special theory of relativity tells is that there is nothing called fixed time. There's nothing. See, what do you tell that? Oh no, I was so and she is dancing. And the other person, I didn't see her dance. And this person, I saw her dance, but after some point, when I looked at her, she is doing a step like this, right? So we are telling, as per this theory, that there is no meaning called there is no meaning for absolute time. There's only meaning for something called space time. So you tell in space, which part of the space, at what time you were, then you saw what. You know, it's a different kind of looking at things. You saw something, well, fine. Where were you in space, and at what speed you were moving? Right? Okay, now we can talk. Till then it doesn't make sense. Understand? If I haven't confused you so far, I will make one more attempt to confuse further, and with that probably we will take this thing.
Just explain this again, spatial and general relativity.
Yeah, I haven't.
I haven't. The dancing example. Continue with the dance example.
Yeah, I haven't come to general relativity. I have only taught special relativity. Whatever you understood is special relativity. Whatever we have talked is special relativity. I will come to general relativity. So if you think about general relativity, so what it means is, if you look at form, now it is coming to your terrain. So let us assume we are talking about now forms. Like till now we talked about concept. Now if you talk about the form of it, what is the repercussion of this in terms of the forms? Then something interesting will emerge. Okay, so you look at it. Let us assume that you are here. Are you able to see my pen? Okay, let us assume you are here. At some point of time you are here, maybe in Mulund or you are Nairoli, someplace. Okay, and at this point some event happens. Right? So now, like what we told, now you're dancing. Who all can see you're dancing? Where all the light will reach from that point, only they can see the dancing. Right? Let us assume that the event happened. here, like you're dancing, you started like this, so it happened at this point. Okay, so where all light can move, light can travel and reach, there are only at such points, people at such points only can see. Let us assume somebody is there is a term which we use to measure distance in science called light year. Light year. So light year is the distance which light covers in 1 year. The distance which light covers in 1 year is called light year. So let us assume another star, another planet is 10 light year away from you, which means they will see your dance after 10 years. Till 10 years they won't see it. Okay, so now let us assume the event is happening here. Okay, the event is happening here. Now from there the light can travel in all directions. So people standing in all directions can see that event, right? So let us assume in 1 second the light traveled this much. Assume in 1 second light travels this much, which means within 1 second this event will be seen by people who are within this circle, right? Do you agree? People who are standing within this circle will see this event in 1 second, because this signal will reach them in 1 second. In 2 seconds, let us assume the light travels this much in 2 seconds, which means the people who are in this line will see the thing in 2 seconds. Okay. Okay. Now, like this, it will go. In 3 seconds, maybe people will see here. Oops, it has gone slightly out of place. Okay. So assume in 3 seconds, let us assume like this, it will go like this, like this, like this. It will spread. It will spread. Okay. So now, this we are talking about space. This we are talking about space. In space, who all can see that event? But then time is also changing, right? After this event, 1 second, this is 2 seconds, this is 3 seconds. Time is also changing, right? So now, very interestingly, if you try to draw something like, you assume this is time. Time is this axis, assume this is space in this axis. If you draw the same thing, let us assume this event is happening at this point. Okay, this circle means this much from here, this much distance this side, this much distance this side is where light reaches in 1 second, right? So now that circle in 1 second, if you draw time in here in this vertical axis, and if you draw space here, then it is right. The same circle, the same circle is true. Same circle is true. Like this, whatever you're telling, it will come like this. But then there is a difference, because after 1 second means in time, let us assume this is 1 second. So this is 1 second means this will be here. Just think about it. This and this is like in a pond we are putting a stone and it is rippling. Water is rippling. So in 1 second it reached here, ripple reach. In 2 seconds it reached further. In 3 seconds it reached further. But now if you take it like this is time, assume this is time. So this started at 0 time. Event occurred at 0 time. But after 1 second story is what we are telling. So after 1 second, space, who all can see is here. So if you draw a time versus space curve, this 1 second story is here, because this is 1 second. Now in 2 seconds, that next curve in 2 second story is here. 3 second story is here. So what happens is, if an event is happening here, who all can see it will go like this. If an event is happening at time 0, who all can go this will go like this. It will go like this cone. So in space and time, only the people within this space and time can witness this event. If you are here, you can't see, because this is the maximum speed at which light can travel. You understand?
Yeah, but why this perpendicular? Like why this
Yeah,
vertical and
yeah.
horizontal?
Why this is perpendicular is this time and space are two different entities. Now you are merging these two. There are applications to it. This is to tell you why is application. This is to tell you, if something is an event is happening in universe, will you be part of it? Will you be ever seeing it? You will see it only if you are in this cone. So this cone will expand now. You see, this cone will expand like this. This cone, but see, so what will happen? Let us assume this is sun. In sun, if assume sun is getting closed, fused in one second. In earth, you won't see that. You will see it after 8 seconds, because you will be somewhere. Let us assume this 8 seconds, you may come somewhere here in earth. So if you are not within this, in this cone, you can't see an event which is happening in universe. So this is what is called light cone. Okay, so form wise, I hope, like normally I don't try to explain this to students. Form wise, if you can understand this as a ripple which is happening in a pond, which is two-dimensional, but when it comes to time, then it becomes three-dimensional. One more dimension get added, space and time. So you assume the first ripple, after 1 second it reaches here, but then if you want to take the time also into consideration into two dimension. So what are we doing here? We are bringing time also into two dimension, because we want to analyze phenomenon, and our paper is two-dimensional. So we can see, we want to bring everything into two-dimensional so that we can analyze. If you bring it, this will look like this, light cone like this. Okay, now if you now extend it before, right before this time, what happened? Where from this light has come? So this point of light or whatever this thing has come. So it will again stretch like this. So you will be part of an event in this universe only if you are in this, inside this cone, present or past. Can you go past cone into? Those all things are what the case of science fiction. So I will show you the actual diagram of this.
But then Satish,
Yeah.
this is what you have shown. That is also an assumption, right? Not
No,
like
this is
these
not
lines.
assumption. No.
Huh?
This is not
No?
assumption. No. This is a representation of what is. See, light is traveling at constant speed, and you can see only things when light comes to your eye, and all are firm theories, are very firm things. They are not assumptions.
How did you achieve this?
It is actually, see,
This this diagram I'm talking about.
yeah, see, diagram is actually our attempt to analyze this in two-dimensional.
I understood this repulsion.
Yeah.
Then ये angle भी समझ में आ गया उसका जो represent किया in angular form,
Yeah.
like circles in oval, that also.
Yeah.
I just want to know why this intersection you took, like time and space.
Yeah, but that is because it is not intersection. I am bringing time also into two-dimensional. See, actually we have four axes here. If you really look at it, we are telling space and time is, we have four things, because space itself is three-dimensional. Space is three-dimensional. 1, 2, 3, right? and then you have time. So you have 4 axes. Now which is very difficult for you to visualize. You when you want to analyze some events happening, you can't go to space and then make 4-dimensional diagram and analyze. You have to bring it to your pen and paper if you want to analyze it. So this is a tool for analyzing it. So this tool is for analyzing it, but what does this tool do is that if you want to analyze a complex phenomenon in universe, you analyze it through light cones and see whether you are in that same light cone. So this enables you to make complex light cones of events and then analyze like who all were part of it, which will be part of it, kind of stuff, right? So let us assume a meteor is breaking in a galaxy or somewhere. Will it affect you, Earth? Will it affect you only if you are inside the light cone? It will not affect you. So the applicability of tool is very heavy, but the basis of it is representation is an analysis, but the basis of it is all like light speed is constant, and you can see only things when light comes to your eye. All those things are very firm footing. I'll show you this also. This is how it looks actually.
Satish, I have one question.
Yeah.
Suppose I'm looking at Mars, okay,
Yeah.
and distance of Mars from our Earth is let's say 3 light years.
Yeah.
For example,
Yeah.
that means what I'm looking,
Yeah.
that is my experience of present tense.
Yeah.
But what I'm receiving, actually, I'm looking 3 light years into the past, right?
Exactly. 3 light years into the past based on your present. When you tell past, based on your reference.
Yeah, which is very interesting.
Yeah.
And when distance get reduces, this experience become more and more subtle.
Subtle,
Right?
or
between
your
the present and past.
exactly. The difference between your timelines becomes thinner.
Yeah.
When the distance reduces. And one more thing what we are telling is this is not only dependent on distance, it also depending on your speed. If you're traveling, if you're traveling fast, what vision you see is different. So now in essence what we are doing, we started with motion, then we came to time, now we coming to vision and telling that your vision is nothing but your time. Sense of time is your vision.
Yeah.
So I have difficulty in explaining this to students because they don't see, they are like normally they get into this thing, but what question will be asked from this portion. Okay. So they will be telling, okay, if speed is increasing, your age will reduce. So they will try to get that logical relationship, because poor kids, they are fearing which question will be asked from this topic. So I have very difficulty in explaining this, but when I am trying to explain to you, I can easily connect with vision. Otherwise I would not have attempted this light cone. Normally this slide I skip. Okay, but this light cone, if you see it as such, you won't understand. But I hope with this 2-dimensional, say when I ported it into this thing, I hope you will understand this. Okay, so now this means if you are outside this light cone, you are not party to the event.
Yeah.
Okay, and this is your past light cone. Okay, so if you are here, you are part of the events which happened here, your past light cone. So this is where people come about time machine by telling, can we move to past light cone, and can we move to future light cone, and all those things people ask. So this word called light cone may use. So if you are getting into science reading, so that is why I thought I will explain this to you. Yeah, so I think that much is enough for the day. Projector, don't kill me for this drawing, okay?
Very interesting, Satish. Thank you.
Okay. Okay.
Bye. Bye.
Bye. So We'll close. Okay. Any,
Yeah.
yeah. Imartha sir, can I close? Yes. Okay. Okay. Bye.